You're welcome.
Okay, let's share my presentation. Okay. Okay, do you see my presentation?
Yes.
Okay, thank you. Good day. My name is Eduard Manzuk, Khmelnytsky National University, Department of Computer Science. This presentation will cover the research on integration of contextual descriptors in ontology alignment for enrichment of semantic correspondence, presented on behalf of the team from Khmelnytsky National University and colleagues from other institutions. The structure of this presentation will be as follows: the introduction to the research, followed by the background and motivation, a brief review of the state of the art, research objectives and methodology, results with a case study, and conclusions, and concluding with key findings and future research directions.
I'm sorry, I see the black screen. Is it only my problem?
Okay.
Okay, I see motivation here. Thank you.
Yeah, да? Something going wrong. I'm sorry. The motivation for this research arises from several challenges in ontology alignment, including semantic heterogeneity across domain and difficulties in capturing contextual nuances. Current approaches often struggle to generalize to new domains and rarely heavy on additional data or expert annotation, with inadequate consideration of semantic and structural factor. There is a significant need for context-aware alignment, as contextual information plays a crucial role in knowledge representation. The integration of contextual alignments has the potential to sustainability, improve alignment accuracy and relevance, enhancing the interpretability of knowledge systems. Looking at the current state of the art, we see several approaches being used in ontology alignment. This includes representation learning techniques, machine learning, and deep learning models, and symbolic or semantic approaches. Recent advancements include systems like VLite, BERT-based approaches, and hybrid methods combining different techniques. We will also see progress in domain-specific alignment, particularly is areas like biomedical ontology, pharmaceuticals, and so on. Emerging trends include cross-lingual alignment techniques, graph-based approaches, and methods for managing ontology evolution. However, we identified several gaps in current research. These include limited generalization to new domains, challenges in quality assessment, and insufficient considerating of contextual factor. We see opportunity for improvement in integration, contextual information developing universal method for heterogeneous ontology, and enhancing consideration of structural and semantic information. Given this background, the main goal of our research is to develop an approach to integrate contextual descriptors in ontology alignment. Our specific objective are to improve the accuracy of semantic correspondence to ensure the relevant use of knowledge in various contexts. Key components of our approach include distinguishing between essential and contextual descriptors, formalizing the application of contextual descriptors in a semantic approach, and creating a comprehensive knowledge model adaptive to real-world conditions. We expect this approach to enhance our ability to capture nuances, semantic relationship, improve alignment performance across diverse domains, and create more flexible and context-aware ontology matching. General of our approach is a distinction between essential and contextual descriptors. Essential descriptors are core in intrinsic characteristic of concept. They are objectively measurable, clearly defined, easily documented, and often have a legal or regulatory basis. Examples include legal framework for PD decision, internal control mechanism, and contracts and legal obligations. Contextual descriptions, on the other hand, are situational or external expect effective concern interpretation. They depend on social, cultural, or situational context, may vary based on interpretation, and often reflect implicit and intangible aspects. Examples include public discussion of accountability, cultural differences in legal liability, and stakeholders' involvement in NI accountability. This distinction is crucial in ontology alignment. Essential descriptors provide foundational matching criteria, while contextual descriptors enhance alignment accuracy in specific scenarios. By distinguishing between these types, we can create a more nuanced representation of knowledge, improve adaptability to different domains, and better capture real world complexity in alignment. At the top level, we have the information scope, which provide a broad categorization of knowledge domain. Below this, we have entities which are concrete and or abstract object within the information scope. Each entity can have multiple properties, which in turn are described by both essential and contextual descriptors. This hierarchical structure allows for a clear organization of knowledge and facilitates more precise and context-aware alignments. It's also flexible, allowing for the additional of new descriptors as knowledge evolves, and enabling cross-linking between different branches of the hierarchy. This structure is crucial as it provides a solid framework for our method, enabling us to systematically process and analyze complex knowledge structure. We begin with a way to connect entities, their properties, and the values of those properties. Think of this as a three-dimensional relationship. For example, if we dealing with AI system, an entity might be a specific AM model. A property of this model could be its decision-making capability, and the value might be high accuracy in medical diagnosis, for example, for practical example. Next, we define a similar structure for what we call essential descriptors. They are the core fundamental aspect of properties. Continuing our example for the property of decision-making capability, an essential descriptor might be the type of algorithm used. This structure links properties with their essential descriptors and the specific detail of those descriptors. We then create a parallel structure for contextual descriptors. There's the aspect of properties that can change based on the situation or context. In our AI example, a contextual descriptors for decision-making capability might be ethical consideration in different cultural contexts. To make practical use of these structures, we defined several ways to extract specific information. For instance, we have a method to obtain all properties value for a specific entity. In our example, this would be like listing all the capabilities of a particular AI model. We also created ways to compare entity based on their properties. This allows us to identify, for example, which AI models have similar decision-making capabilities, which is crucial for alignment task. Finally, we developed a method to combine all descriptors for a comprehensive description of a property. This gives us complete pictures of each property, including both in fundamental aspects and how it might change in different contexts. By structuring our approaches in this way, we create a robust framework for handling complex knowledge. This allows us to systematically process and analyze entity, properties, and descriptors, providing a solid framework for our ontology alignment method. It enables us to capture the nuance of both essential and contextual aspects of knowledge, leading to more accurate and context-aware alignments. This structural approach to representing knowledge allows us to handle complex relationships in a systematic way, which is essential or effective ontology alignment. It helps us to understand not just what things are, but how they are relative to each other and how this relationship might change in different situations. This comprehensive view is that allow our method to create more accurate and flexible alignment between different technology. Let's look at concrete example of how we apply this approach. Here we have a table showing properties, descriptors, and type of the concept of responsibility in AI ethics. You can see how we categorize different aspects of responsibility into properties like AI decision, accountability, legal liability, ethical ethics, and so on. For each property, we defined both formal, essential, and contextual descriptors. This detailed breakdown allows us to capture not just the core aspects of responsibility in AI, but also how these aspects might be interpreted or applied differently in various contexts. To ensure consistently in our approach, we have developed specific criteria for classifying descriptors as either essential or contextual. Essential descriptors are those that are objectively measurable, easily standardized, and often have a legal or regulatory basis. Contextual descriptors, on the other hand, depend on social and cultural context, may vary based on interpretation, and often reflect implicit aspects that can change over time. For our experimental research, we developed a generality similarity calculation and takes into account both essential and conceptual descriptors. This formula considers the number essential and contextual descriptors, their similarities, and the number of sources supporting each descriptors. Our experimental results show significant improvements in various indicators after implementing contextual descriptors. And as you can see in the graph, we observed increased across all measured aspects with particularly notable improvements. For example, in privacy, about 7%, responsibility, about 5%, and for example, freedom and autonomy, also about 5%. This result indicate that our approach leads to a more comprehensive understanding of AI's role in addressing social and environment issues, as well as increased attention to data protection, including the definition in AI responsibility and ensuring user autonomy. It concludes our research has successfully developed a novel approach to ontology alignment by integrating contextual description. We enhanced semantic correspondence determination through comprehensive knowledge modeling and create a framework for contextual-aware knowledge representation. Our approach often more accurate reflection of knowledge complexity and contextual dependence, improving adaptability to various domains, and an enhanced ability to capture nuanced semantic relationships. While our method may be less effective in areas with insignificant or changing context, it often promising path for more accurate and flexible ontology alignment in most real-world scenarios. Looking ahead, we see potential for future research in optimizing weight coefficients and develop method for automatic parameter tuning for different domains. This could allow for even more effective use of contextual descriptors in ontology alignment. Thank you for your attention. Any question are welcome.
Thank you very much for your comprehensive report. I have some questions. I want to ask, is it related with your Doctor of Science thesis?
Yes.
Yeah, I wish you good luck in this area.
Thank you very much.
The next question, what are the practical applications of your research and which companies can implement your results in their activities?
One important question that I can to say, a problem of different ontology alignments was mentioned in a paper paper Jobbins, the global landscape of AI ethic guidelines. The problem of difference in defining the ethical aspects of AI was not in this paper. It arises in difference from social culture in the situation context. We can make more flexible diagnosis, for example, in medical or pharmaceutical context. Then we can enlighten different scientific papers, scientific studies, and make more accurate decision-making process. I guess so.
Yeah, thank you. Maybe someone else have some questions. It seems no questions, so thank you again.
Thank you.
Okay, and we have the last report in our section is number 174. But I think it